Hello everyone, welcome to the session on compilers. In this session, we'll be discussing about top-down parser. In this session, we will see what we mean by parser. We will see what are the different types of parser, and then we will see what is the top-down parser with suitable example. Friends, as you know that you are viewing this session on my YouTube channel Learn with Prakash Kanale, and subscribe to the channel to see many videos on the subjects of electronics and computer science. So let us start the session with the question what we mean by parser. Now we know that whenever we write any program in the high level programming language, then this program is not in the understandable form for the computer machine. And therefore this program need to be compiled by using the compiler. Now, the first phase of the compiler is called as the lexical analyzer, and the second phase of the compiler is called as the syntax analyzer or parser. So parser is just nothing but a syntax analyzer. That is, whenever we write some program, then we need to obey the grammatical rules of the programming language. Like the natural language, every programming language is associated with certain grammar rules. And these rules you need to follow whenever you write any program. And whether you have followed these rules or not, it will be checked by using a program. And this program is being called as the syntax analyzer. So the syntax of the input program can be checked by using the program, and this program is being called as a parser program. So parser is just nothing but a software, or you can say that it is the second phase of compilation. At the input of the parser, we have a sequence of tokens because we know that whatever we write in the program, at the output of the lexical analyzer, it is being converted into a sequence of tokens. And the sequence of tokens is fed to the syntax analyzer. And at the output of the syntax analyzer, we will generate the parse tree, or sometimes it is called as the abstract syntax tree. Say, for example, we have written a small code, something of this form, 437 plus 734. Now, when we connect such code to the lexical analyzer called as the lexer, then at the output of the lexical analyzer, we will get a sequence of tokens. That is, a token will be generated for the number 437. A token will be generated for this operator plus. A token will be generated for the next number 734. So this sequence of tokens will be fed to the parser. And at the output of the parser, we can expect a syntax tree, something of this form. Expression, where it will have a sum variable, where the sum variable will have the first argument 437, the second argument will be the operator plus, and the third argument will be the next number 734. So if the parser is able to impart a structure to the input string, then we can say that it is successful completion of the parsing. But if the parser is not in a position to impart this syntax tree structure to the input string, then we can say that it is a syntax error. So parser program is written by using any programming language. And the parser program, basically what it will do, that it will do either the leftmost derivation or the rightmost derivation. Already we have seen that the grammar of the programming language can be described by a context-free grammar. And in the context-free grammar, whenever we have been given some input string, then for that input string, we can construct the leftmost derivation or the rightmost derivation. So parser program will also do the same thing. That is, it will construct either the leftmost derivation or the rightmost derivation. And if such derivation is not possible, then the error will be generated. And this error is being called as the syntax error. And now we know that every compiler will have an error handler, and therefore the user will be prompted about the correction in the program code so that the error can be removed. Now let us see what are the different types of parser. There are different types of parser such as top-down parser and bottom-up parser. The bottom-up parser is also called as the shift-reduce parser. So parser program is basically categorized into two categories. The first category is called as the top-down parser, and the second category is called as the bottom-up parser or shift-reduce parser. The top-down parser can be further divided into two categories. The first category is called as the recursive descent parser, and the second category is being called as the predictive parser or LL parser. The shift reduce parser can also be further divided into different categories such as LR parser and operator precedence parser. Further, we can have the different types of LR parser such as LR, SLR, LALR, and CLR. So LR, that will stand for left to right with rightmost derivation. That is, in LR parser, the input string is scanned from left to the right, and the rightmost derivation is performed in the reverse order. And SLR, it will stand for simple LR parser. LALR will stand for the look ahead LR parser. So we have different versions of LR parser. So considering certain issues with the grammar, the different versions are there for the LR parser. Also, we have a parser called as the canonical LR parser. The top-down parser, as I told you, there are two types, recursive descent parser and LL parser or predictive parser. In this LL parser, the first L, it will stand for left to right scanning, and the second L will stand for the leftmost derivation. So in LR parser, we know that the rightmost derivation is performed in the reverse order. And in top-down parser, what we perform is the leftmost derivation in the forward direction. So in this session, we'll be discussing about this top-down parser, the basic theme of the top-down parser. And then later on in other sessions, we will discuss in detail the predictive parser and the recursive descent parser. So many times you will find that these parser programs are used by most of the languages. So it is possible to write the parser program for any given high level language. Either you can go for the top down parser or you can go for the bottom up parser. So now let us start with what we mean by the top-down parser. The top-down parser basically will consist of an input buffer where we can store the input sequence of tokens. It will consist of a stack memory. It will have a parsing program, and it will have a parsing table. And then there will be an output in the form of the parse tree. So in top-down parsing method, we start from the top. The top is just nothing but the root. So we start from the root or the start symbol of the grammar, and then we go down, and then the parse tree is being constructed until we are able to reach to the leaves. That is, until we are able to reach to the input sequence of tokens. So in this method, as I told you, that the leftmost derivation is being performed, and the leftmost derivation is performed in the forward order. The top-down parser, as I told you, will consist of the input buffer. The input buffer is used to store the input sequence of characters or tokens. The stack memory is used to store the grammar symbols. And then there will be a parsing table. The parsing table will be consulted by the parsing program in order to perform any action. And then we will have an output, and the output will be in the form of an abstract syntax tree or parse tree. Top-down parser will suffer from certain problems. Say, for example, in top-down parser, we may need the backtracking. So backtracking means, suppose if there is a production rule which has two alternatives, and now suppose you follow the first alternative, and if you are not able to reach to the input string, then in such a case, you need to backtrack all the symbols. That is, you need to make the movements undo. And since you have to try for the another production rule that is being available in the grammar. So this is a kind of a problem that every parser need to face, and always we need to find some solution to the problem of backtracking. So By making the use of the look ahead symbols, it is possible that we can resolve the problem of the backtracking. Left recursion is the another problem that is being observed in case of top-down parser. Say for example, we have been given a production of the form A is defined as A beta. Now, when we go for the leftmost derivation, in the leftmost derivation, when we try to replace the symbol A, which is the leftmost symbol, then again we will find that we are having a loop, isn't it? Because A is defined as A beta, and therefore such type of the production or such type of the grammar is being called as the left recursive grammar. So it is necessary to remove the left recursion before we actually use it in the parser program. Now let us understand the simple steps that are being obeyed in any top-down parsing algorithm. Initially, the stack of the top-down parser will be an empty thing, and it will contain only the start symbol of the grammar followed by a $sign. The input buffer will consist of the input string, which is to be parsed, and also it will be followed by a $sign. So $sign will indicate the end of the input string. Now the parsing program has two pointers. One pointer will point to the current input symbol, and the another pointer will point to the top of the stack. Now, according to the position of the input symbol and the top of the stack, the parsing program will consult the parsing table, and then as per the action mentioned in the parsing table, it will perform either a push action or the pop action. In the push action, the characters are shifted to the stack as per the production rule of the grammar. And in the pop action, the top of the stack is being reduced or is being removed. So if this process goes on, and then if we find that both the stack and buffer consist of only a symbol of the grammar, and if all the symbols of the input buffer are exhausted, then we can say that it is a successful completion of the parsing. Otherwise, you will find that the error message will be generated, and this error is being called as the syntax error. Now let us see one simple example of top-down parsing. Suppose we have been given a context-free grammar for expression having the following production rules. E is defined as TE dash, E dash is defined as plus TE dash or epsilon, T is defined as FT dash, T dash is defined as star FT dash or epsilon, F is defined as bracket of E or ID. So in this grammar, E that will stand for the expression, T that will stand for the term, F that will stand for a factor, ID that will stand for identifier, and epsilon is just nothing but an empty string. Now suppose we have been given input string ID plus ID star ID. Now we can easily check by using the top-down parsing whether the input string belongs to the grammar or not. Now, for such a case, we need to perform the leftmost derivation. So in order to perform the leftmost derivation, we will start from the start symbol. E is defined as TE dash. And whenever we are doing the leftmost derivation, we will write LM. So it indicates that it is a leftmost derivation. So we will make the use of the first production rule. E is defined as TE dash. Then we will replace this T by FT dash. Then we will replace this F by ID. Then we will replace this T dash by epsilon, but since epsilon is empty string, therefore it can be removed. And then we will replace this E dash by making the use of plus FT dash. Then the F will be further replaced by ID. Then T dash will be replaced by star FT dash. Then F will be replaced by ID. And then T dash will be replaced by epsilon. So finally, you will find that we will get the input string ID plus ID star ID. So one can easily say that this input string belongs to the grammar, and therefore there is a successful completion of parsing. Now we can easily obtain the parse tree for such a leftmost derivation. So E, we have started with the starting symbol of the grammar E. E is derived as TE dash, then T is replaced by FT dash, then F is replaced by ID. Then we will replace T dash by epsilon. Then we will replace E dash by plus T E dash. Then we will replace this E dash as T, and T is being replaced by FT dash. Then we will replace F by ID. Then we will replace this T dash by star FT dash. So we go on doing it. These are the same steps that we have derived earlier. The only thing is that we are representing them in the form of the syntax tree. Then we will replace F by ID, then T dash is replaced by epsilon, and E dash is also replaced by an epsilon. So finally, you will find that we will get the same string ID plus ID star ID. And therefore, we can say that it is possible to construct the syntax tree or parse tree for the input string, and therefore, there is a successful completion of the parsing. So thank you friends for viewing the session. Hopefully you have understood what we mean by top-down parsing and how top-down parser works. Thank you all for viewing the session.